Welcome. So this question says a pendulum swings from A to B to C. So this is A, which is one extreme. Then it swings downwards through B and it goes to C. It will go onwards. It's going to be symmetrical, but we're not referring to this, if you like, point D. So a pendulum swings from A to B to C. At A, it has a gravitational potential energy of 7. So this would be UG equals 7 joules and a kinetic energy of 0 joules. And I'm going to basically ask questions about different values for the gravitational potential energy and different values for the kinetic energy at different points. So the first question is, what is the EM, which is the mechanical energy? And from conservation of energy in a isolated system, we can say that the mechanical energy at A is the same as the mechanical energy at B, is the same as the mechanical energy at C, because no energy is gained from the outside of the system and no energy is lost through friction, for example, to the outside of the system. So we say EM is equal to, let's talk about A, is going to be equal to the kinetic energy at A plus the UG, the gravitational potential energy A. We have no springs here, so we won't even bother talking about the spring potential energy. Okay, so EM is equal to, and if I look at A, we can see that K is 0 because it's stationary at the end of its swing, plus UG, the gravitational potential energy, was 7, so EM is equal to 7 joules. So that's the first bit. We know that EM here equals 7 joules. And by the way, if EM here equals 7 joules, then let's change colours for this bit. We know that the mechanical energy here equals 7 joules because that doesn't change. And we know at this point here, which is the lowest point in the trajectory, in the path, we know that at that point, the gravitational potential energy must equal 0 joules because it's the lowest point. And so we say, what is K at B? Well, our relationship is that our mechanical energy at B is equal to our kinetic energy at B plus our gravitational potential energy at B. And we know this mechanical energy is 7 because we worked it out for point A. And we know that this gravitational potential energy at B is 0 because it's the lowest point on the swing. And so KB can simply be said by KB is equal to 7 joules. So what happens is that all the mechanical energy is stored as gravitational potential energy at A, and then it gets transferred, and by the time you get to B, all the mechanical energy is stored as kinetic energy at B. Now let's look at an interesting case where we look in between these two, and we look at point C. And at point C, we say, well, let's continue. So the mechanical energy at C must equal the kinetic energy at C plus the gravitational potential energy at C. And we know, we've been talking about this all the way along, the mechanical energy anywhere at any point in this system is the same. It's 7 joules. But now we know that our kinetic energy at C equals 2 joules. So that will be 2 joules plus, and it's asking what is the gravitational potential energy at C? Well, 7 minus 2 must equal my gravitational potential energy at C. So that must equal 5 joules. I didn't put any boxes around any of these things, but let's just tidy up a little bit. Now, So what went on here? We recognized that this was a isolated system, and therefore the mechanical energy was constant throughout. There was no friction involved, that's the key thing. We recognized that the mechanical energy at any point would be given by the sum of the kinetic energy at that point and the gravitational potential energy at that point. And we just let the sums take care of themselves. Just before I leave this, I want to be just a bit, want to point out that I can make this question a little bit more interesting. For example, rather than asking you what would be the gravitational potential energy at sea, I could give you the mass. I could tell you this is, at the surface of the Earth, so you know that the gravitational field strength is 10 newtons per kilogram. And I could ask you for the height. How high is point C above the baseline? What is this height? By the same token, I could give you the height. I could tell you the gravitational potential energy. I could not tell you the kinetic and ask you for the velocity at point C. I could give you the velocity and the height at point A, and then have you work out from those two what the mechanical energy is. So I can go one step beyond, rather than just talking simply about the mechanical energy equals the kinetic energy plus the gravitational potential energy. I can kind of make you work for this and make you recall that this is equal to K is equal to a half mv squared, and I can make you recall that UG is equal to mgh. So I can make this question more interesting, but the key point is the relationship, which is that in an isolated system, the mechanical energy is equal to the kinetic energy plus the gravitational potential energy. And if there were also a spring, which there might be, that would also be added into the mix. So that's a fundamental relationship for isolated mechanical systems. So there we have it.